Right, in a previous screencast I have connected a sinusoidal generator with a waveform indicator. Here I have added another sinusoidal generator and merged this signal. This little merger can be added by signal manipulation and this, so it's a rather trivial operation. It has two ports here, and input ports are connected to the generators, and output goes to the waveform graph. Now this sinusoidal signals have different frequencies, so all the other parameters are the same. So that has 10 Hertz, okay, and the other one should have 20, I think, yeah. So basically it's a trivial extension of the previous system, and I can run it to show that I have indeed one waveform twice as quick as the other. So the red curve corresponds to 20 Hertz. Okay, so I can stop it now, and what I'm going to do now is to add some basically I want a second signal to be a second harmonic of the first signal. To do that I have to introduce some additional controls. First I want to add to have an input for a signal period. That I'll put it in a simplest possible input field, and I want to call it period. Okay. Now here we can customize those by simply pressing the right button and choosing properties. So these are properties of my signal. It is called period. Data type is double, which is okay, I want that. Data entry, of course I have a numeric for type double. I have my signal period should be a positive number, and I want it to be between 0 and let's say 2 seconds. Okay, with increment of 0.1, if that is right. I can re-enter this if I like, but that's the way I want it. Okay, so all the other things are more or less default. Right. Okay. So it is currently disconnected, but if you look at the signal shapes, the signal properties, those have actually amplitude and frequency. So I want to have frequency, not period. I want to specify period, but the frequency should be calculated. So in order to do that, I will insert a script similar to MATLAB script, so that I have to find programming tools and get the scripts in structures. Okay, that math script. The syntax of that is identical to MATLAB script, so that should appear now. Come up. Well, the angular frequency has to be like let's let it be called omega, equal to 2 times pi divided by t. T is currently undefined. I'll put semicolon just in case. And I want it to be fed from this input field, input control. So I want to insert add an input, and that is a little connection point, and I want it to be called t. Okay, now I have a variable here, and I will feed the actual value to this input field t. Okay, that's the way I want it. And now I want to feed omega over to, well, actually it should be normal frequency, not an angular frequency, so that 2 pi isn't there, and that is frequency. Okay. Now I have two variables here, t, which is an input thing, and fric for frequency, which should be an output parameter. And I want to add output, and it offers me a choice of 2 naturally, and I choose the frequency. So that frequency goes to, okay, let me see, that frequency should go to the first. I want it to be the first, okay, and that's getting a bit messy here, but I will sort it in a second. So if I collapse this thing, I see that the second terminal here corresponds to frequency. So that one is frequency. Now what I want to do now is to create a double frequency for the second generator. So basically I want to introduce a frequency multiplier. That is a signal manipulation. No, that's the arithmetic thing. Numeric, that is multiplied by constant. That will be it. So it has two inputs, one output. One output goes to frequency, which is what I want. One input goes to this frequency, that is, and secondly I want to have arithmetic constant. I can find it in well, this arithmetic and other things here, and I want it to be just 2, okay, and this constant multiplier is here. Now what I have now, the first harmonic goes to the first fundamental frequency is corresponds to the first generator, and the same frequency multiplied by 2 goes to the second, and that should be twice as quick, and I can do a period provided by my controls. Okay, now I think it's ready to go. I'll simply run it like so. I think my okay, the reason is that I have provided a horrible number for the frequency, so that I don't do checks here. Apparently it's division by 0, and that is the problem. So I provide a period of 1 second, okay, and we'll try to run it again. Now it runs like so. I think if I will do 0.2 seconds, that makes it a little bit better. 0.1 probably. I can actually do that. 0.1 and run it. Okay, that's the way to do it. It is now all sort of calculated. My signal period is given here in numerical control, and frequency is calculated now, and the two generators are synchronized so that the white curve corresponds to the first generator and the red curve corresponds to the second generator, and indeed the period of the red signal is half as long compared to the original signal. Okay, that completes the job, and thank you for watching.